Especially on the constructed response. Hopefully I get fewer turned in blank because some of them are really honestly simple. Some of them say, is it positive or negative? Is it a good fit or not? Is the correlation strong or weak? Like literally 50-50 chance there. But the first request was for number one on the constructed response. So we have a company that makes toys, has many different varieties that people can order. The company keeps track of the number of each variety that they make and the average sale price for the toys having that variety. They create a scatter plot using the data with the number of toys along the x-axis and the average price per toy along the y-axis. First thing you need to do is draw a line of best fit. Thank you. First thing you need to do is draw a line of best fit. So I shouldn't really expect any words or anything over here. I'll be looking for it here when I grade it. For it to be a line of best fit, where does it need to be in relation to the data? Close to the point. Okay, does it have to touch all the points? So there could be lines of best fit that don't touch any of the points. Yeah. But they should go through the middle where the points seem to be clustered around it. So I mean, to you, that might be the middle. I don't know. I think to me, this is the middle. But you want to draw it toward the middle of your data where the points seem to be clustered around it as straight as we possibly can. Now, on your test tomorrow, you'll have a packet and a separate paper test like we normally do. Use the packet to help you make that straight line. Like line it up, find where your middle is, draw your straight line. That's important because for the next question, you need to write the equation in y equals mx plus b form. Stop. You need to write the equation in y equals mx plus b form to represent the line of best fit, the one that you sketched. That's why you want it to be straight. 8. In y equals mx plus b, what is usually replaced with numbers?
The m and the b.
So when I say I want an equation in y equals mx plus b, I need you to estimate the slope and y-intercept. Typically, the slope we start with, because if the y-intercept is not visible, then you need the slope to estimate it. And how do I estimate the slope? Emily, please stop. How do I estimate the slope? Okay, so I need 2 coordinates so that I can use the formula that Caitlin's talking about. I don't know if you said it like the formula or you're just saying like the coordinates of it, but that formula is y2 minus y1 over x2 minus x1. Am I providing you that formula tomorrow?
No.
No. So you have to memorize it. It's basically rise over run. It's having you find the difference in the y's, dividing by the difference in the x's. I wouldn't recommend rise over run for these, in my opinion, because the sig marks are not necessarily easy to work with. When it's 2 points from the line, I recommend this one. Now, you need to pick 2 parts of the line that you can see really clearly without having to estimate, and that'll be your x1 and y1, and then the other one, your x, y2. So like for me, looking at it, this looks like something I don't really have to estimate. You see how it's like right in the intersection of the grid line? It goes right down the middle of it. That's what I mean. Was that a data point? No, it doesn't have to be. Sometimes it can't be any of them because sometimes none of them fit nicely on the line or they're hard to estimate. Remember, coordinates go in the order x, y. That seems to be where people are making mistakes. So y, x, those x, y. And that's one that I don't have to estimate, so I'm going to use it. I need one more though. Anyone want to say one that they can see clearly without having to estimate? Sorry, what was that? 8:45, you mean? Okay, if this is what you're talking about, then yes. And there could be others you picked, like 4:55 could be another good one. But whatever you pick, make one of them x1, y1. The other one x2, y2. And plug it in and solve. So the way that I labeled it, it would be 45 minus 50 over 8 minus 6. So y2 minus y1 top x2 minus x1. It should be that the numbers from the same coordinates are on top of each other in the formula. Okay, if they're like mix match, like across from each other, then that doesn't work. Okay, so anyway, we are solving what's 45 minus 50. -5 is correct. 8 minus 6 is. And for the comparing purposes, because like when I make my answer sheet, I might not have written the line like you or pick the same points. That's okay. I'll be looking for it to be close to this decimal, -2.5. So it's -5. So if some of you already had it done, that doesn't mean you have to like erase this. If your slope was close to -2.5, then you did it right. Like -2, maybe even -3, but like somewhere close, not way far off.
What if there's like +1?
It's definitely not right, because is this a positive slope? Is it going up from left to right? So yeah, that one would be too far off. All right, make sense? Good. So then this is my slope. My y-intercept is not easily seen. If it was, I'd just estimate where it's touching. Since it's not, I'm gonna have to plug it into y equals mx plus b. But now that I have the m, that should be easier. So the m is -2.5. The x and y can come from one of these that you wrote. So I'll pick this one. So my y would be 50. My x would be 6. All I did was plug it into y equals mx plus b. When you only have one variable to account for, then you can actually find the value of that variable. So -2.5 times 6. I'm gonna put that in my calculator real quick. Okay, 2.5 times 6, and it's negative. I get -15. I think in another class I used a different XY to plug in and it was -20, but you'll see it ends up all being close. Anyway, -15 plus B. How do I get the B fully alone? Do we forget one-step equations? You're gonna have to add 15 to both sides if you want to make the -15 cancel. -15 plus 15 is 0. And then whatever you do on one side, you have to do to the other. So that's how I isolate the B, otherwise known as y-intercept. 15 plus 50 is 65. So when I put it together in slope-intercept form, it's y equals -2.5x plus 65 approximately. When I grade it, it'll be close to this, probably not exactly this, because the odds of us making the exact same line and picking the exact same points in every step, a little unlikely, but it should just be near it. And that kind of does make sense because when I look at how I drew my line, if I were to extend this, doesn't it look like it would touch at about where 65 would be? Yeah, it's just I couldn't tell for sure, so that's why we estimated. Good on that one. All right, questions on any other parts of the study guide, online or
Yeah,
paper?
could you go to the one writing on that, please?
Okay, sure. So this one has to do with what you were supposed to learn yesterday, I believe. Yes. Correlation versus causation. So a group of biologists is studying the population of wolves and the population of deer in a particular region. The biologists compared the populations each month for 2 years. After analyzing the data, the biologists found that as the population of wolves increases, the population of deer decreases. After reviewing the findings, a news article states there's a strong negative correlation between wolf population and deer population. The increase in the population of wolves caused the population of deer to decrease. Side note, I do like kind of drawing it out. We're saying that as the wolves increase, the deers decrease. So I'd expect it, and it did say strong negative. I'd expect it to look something like this if it was a scatter plot. Then it says, what does it mean for the relationship between the variables when the correlation is strong in this situation? So what do you guys think? What does it mean when we say it's strong? If there was a line of fit drawn on there, it'd be really close to it. So it looks more linear. So you could say that, what does it mean for the relationship between the variables when the correlation is strong in this situation? You could say the data is very linear, something to that effect, if it's strong, and close to a line of fit. Honestly, that alone might be enough. But really, like when it is strong, the data is very predictable. So you could say that too. Kevin? Okay, so then the linear model values are close to the average. Something to that effect. All right. Part B. So, like I mentioned before, of all the tests, this one had very few actual calculations to do. So on this one, more than any others, I do expect some sentences. Make sure that you write the sentences so that I can read it. So if I have to guess, like I'll probably get it wrong. If I have to look at it that hard. Just read sentences, answer the question. Part B, what does it mean for the relationship between the variables when the correlation is negative? So if I say it has a negative correlation, I know that the data is
Going down.
okay. So you can say the scatter plot has data points going downward, something that tells me you know what it means for it to be. The scatter plot data goes down from left to right. Something to that effect. You could say that as X increases, the Y decreases. Basically what it means. As X increases, the Y decreases. Otherwise, if they both increase at the same time, it'd be positive. So. All right, last part, what is wrong with the statement made in the news article? So the news article said that there's a strong negative correlation between wolf population and deer population. The increase in the population of wolves caused the population of deer to decrease. What's wrong with them saying that? All right. Do you think actually the news article is right, that wolves cause the deer to decrease?
Population.
Okay, so just because there is a strong correlation, which there is, they said that, and it is really predictable, that does not mean that there's causation, and that's what you guys were supposed to learn yesterday. Very rarely is there causation. Causation is really only occurring if there's nothing else that causes it. If you watched the video yesterday, it's like the sun gives you a sunburn, right? The sun caused your sunburn. Could anything else cause your sunburn? That would be causation. Can there be other reasons that the deer population decrease? Like what? Hunters,
No grants.
no grass, no food for the deer, natural disaster that for some reason only affects deers and not wolves, who knows? But if you can think of even just one other reason, then there's probably no causation. So you could say something about that. So just because there is a strong correlation, there is no causation because there can be other reasons for the deer population to decrease. For the deer population to decrease. All right, so yes, it is predictable when it's strong, but there can be strong correlations without causation. So if you're ever in doubt, it's probably not a causation. Questions on that one? Questions on others? Could be from the online, could be from the paper. Amaya? Is it number 2? Okay, so this one I can see can be tricky just because of the fact that it's decimals instead of like the normal numbers that you're used to seeing. They didn't provide you any of the normal numbers. Guys, it's fine if you don't need help, if you're so smart and you'll get an A because you already know this stuff, but like I think it is a bit. In this relative frequency table, I know that they are dividing whatever the numbers were before. I know that they divided them by however many people were surveyed, because in that bottom right corner is a 1. And when it's decimals, the highest you can have is 1. When it's a percent, the highest you can have is 100%. So I know they divided whatever it was by however many were surveyed. The proportions should still be the same for when we get to the next part. Like, you don't have to know what the numbers were before. But it says, which of the following statements are true based on this information? So the probability that a student likes baseball, given that the student is between 11 to 13 years of age, is 0.34. So in each of these, you're calculating a conditional relative frequency. So maybe it's not by the total that were surveyed. It didn't say out of the people that were surveyed, how many are this and this. It said, given that. Whenever it has phrases like given that, among those who, out of the people who, blah, blah, blah. Whatever follows that is going to be your denominator. So if it says, given that students are between 11 to 13 years of age, how many students were 11 to 13 years of age? According to this table.
About 35%.
Okay, good. That's gonna be my denominator. Out of those students, how many of the 11 to 13-year-olds like baseball? 0.12, and it's this one. It happens to be the same as that one, but this is what I'm dividing to see if that matches the answer. So 0.12 divided by 0.35 is 0.34, which that's what it said it was. All right, feel free to try that out in your calculator. So the math isn't hard, it's just knowing what to divide by. And it did say which of the following are true, so I'm guessing it can be more than one. Or is it just one, since it only lets me pick one? All right, so I already found it on my first try. If you see any of the other ones, like for example, let's just look at the next one. It says the probability that a student is 14 to 16 years old, given that, so there's that phrase again that tells you whatever they say after is going to be what you're dividing by. So it says, given that the student likes basketball, how many students like basketball? All right, so then we're getting that from there. And we want to know out of those students, how many are 14 to 16 years old? Out of these, how many are 14 to 16? 0.08. Divide that. 0.08 divided by 0.35 is 0.23. Oops, that doesn't look like it. 0.23. And then when I check that answer, it says it should be 0.08, and it's not. That's what it would be if I divided by the grand total, which I did. So questions on this one? Questions on others? Okay, so number 3 on this one. This one was one that I was not here for. It was, I think, last Friday. So residuals. Luckily, the question I think is easy about residuals. Residuals are your actual values minus your predicted. So more like your actual Y value, if you will, minus your predicted Y value. And the actual comes from your scatter plot, like the actual data you gather from like a survey or experiment. The predicted comes from your linear model. So residual plots, which are what's shown here, they always put them around the x-axis because for each x, you have an actual y and a predicted y. Ideally, if you have a really good linear fit, those residuals would be 0, because that means that they match. So when I'm looking at these, you want it to be close to the x-axis. And I also showed you how to do it with technology too. So like, it's different from trend line, but it's also similar. You want it to be near the x-axis where you have some points above, some points below. So take a look at what I have on my screen. It's probably different from most of your screen. Right, there's A and B. There is C and D. Out of mine, which one seems like it'd be for the best line of fit? All of that once. So which one has it where it's close to the x-axis and some points above, some points below it? C is the best because A only has like one above it. It should be like equal amounts. Because ideally you would want your line of best fit to go through the middle of your data where your points are clustered around it. Same thing for residual plots, except for it's centered around the x-axis. But the stronger it is, the closer it is to the x-axis, and like it should still be through the middle of your data. questions on that? Remember that aspect, and then that's really all you needed from that list. Other questions? It would have to be really quick. On this one. All right, so Jen periodically kept track of the cost of the product and sales in millions over an 8-year period. Which equation is the best model? So it's kind of like number one on the constructed response, except for you do have some options. Unfortunately, you can't draw on your computer screen. At least tomorrow, you will have the packet of the questions that are online, so you could still draw. Okay, guys, hold off. Just wait. Thomas, I'll give you time if you let me talk for at least 1 minute. If not, I'll just keep going and you can make one done. All right, so you would want to picture where you can draw a line going through your middle of your data. Of course, that's hard when you're on a computer screen, and that's not even perfect the way that I drew it. But similar to what you did before, you're going to want to pick 2 points that you can see without having to estimate a whole lot. And then plug it into your slope. I don't think I'll have time to show you that part. But you can kind of estimate where your y-intercept would be near. What would it be near? The way that these are counting are by 1, so it's tick marks. So it'd be like close to the 9. Looking at my answer options, there's some that are really far from 9. Like C has a y-intercept of 0. This might still even be a little too far from 9. I really have to look at my slopes and then compare my answer options. Both the slope and y-intercept should be close to my answer. I didn't answer this in my earlier classes. You'll have a better explanation than what I could squeeze in right now.